All right, in this video we are gonna work with calculating volume of triangular prisms and also rectangular prisms. And we want to remember that volume is just basically saying how much space does something take up. And so when we're thinking about volume, we're really asking how much does it take to fill it up. So if we look at this example here, it says 200 units cubed. That means that 200 cubes that are 1 by 1 by 1 fit inside here. 200, that's what that means. Okay, so now the application problem, we're going to find the volume of a triangular prism. And so we've looked at it a few different ways. We know that we can well, actually we haven't looked at a triangular prism. So if we think about what that's made out of, we've got a triangle on top. These are rectangles here on the sides. And so we could start by just taking a look at that bottom layer. We've got a bottom layer, that's a triangle. And I've got a base of 5 and a height of 6. And so I could just first find the area of my triangle. And I could do that by just thinking about how does a triangle relate to a rectangle or a parallelogram in this case. Well, it is half. If we look at the relationship, it's half of a rectangle. And so if I have 6 times 5, I can multiply times 1/2 to show that I've got half of a rectangle. So this would be 15 centimeters squared. Okay, and so what we just did is we just found the base. And so one way to think about it is we've got the base now, and we want to look at how many layers do we have. Okay, so one strategy is to calculate the base and look at the layers. Well, it says here that we have 4 meters, so that really means that this has been split into 4 layers. Okay, and so we've got 1, 2, 3, 4 layers. 4 layers. So if we think about that, we just calculated that the bottom layer is 15. Then there's another layer, another layer, another layer. So essentially we can take our 15, which is the bottom, the area of the bottom, it's like that flat surface, and then we can multiply it and build it up, each layer, and multiply until we get 4 layers total. And when we have 4 layers, then it's 60 meters, or centimeters, sorry, cubed, because now we're dealing with a 3-dimensional shape. We started with an area, and then we built layer upon layer upon layer until we had 4 layers in total. And another way I can check that is by simply, if this was a rectangle, pretend this is a rectangle for a minute, I could ask myself, or I could do length times width times height. Length times width times height, right? But the fact that I'm dealing with a triangle means that I have to take my length times my width and cut it in half. So it would look more like 1/2 5 times 6, because that's the triangle part, times the 4 layers. Okay, and if I do that, do I get 60 cm cubed? Yes, I do. Okay, so it's basically, this is the top. You look at the connection. This is the area of the bottom, the base. Then we're multiplying it to build a 3-dimensional shape by adding 4 layers to it. Okay, now, sorry, I know this isn't my best video ever. So if we look at this, guys, this is the homework from yesterday. So I want you to take a moment and correct the surface area and Net's homework from yesterday. And then next step is, done with that. The next step is your job is you have 2 problems to do by yourself tonight, or not tonight, today. And your goal is to, this is a rectangular prism. You're going to basically follow those steps we did in the last one. So here we've got a 3 by 3 by 4 shape, and we need to find the bottom layer. Okay, we want just a 2-dimensional the area of the bottom layer. And then we're going to look here to figure out how many layers are we building up on this shape. And then you're going to calculate the volume. And then this is a triangular prism. And when you get ready to solve this problem, I'll tell you there's one height on the triangle. I'm going to draw this over here, but if you think about the triangle, there's one, measurement that you don't need. One is extra. Okay. So, and you can use the triangular prism that we did when we first came in to try to solve this problem. Okay, thanks for listening.